The Polymide family of materials are all nylon-based engineering filaments consisting of different blends of nylon and combinations of fiber reinforcement. If you're unsure about the differences between PA6, PA66, Co-PA, PA12, then let me take a minute to explain the differences between these materials and their advantages. The first material in the Polymide family is Co-PA. Co-PA is a copolymer nylon consisting of the two most widely used nylons across all industries, which is nylon 6 and nylon 66. Nylon 66 offers higher heat resistance, more dimensional stability and abrasion resistance, while nylon 6 lowers the melting point, lowers the crystallinity and reduces shrinkage. Together as a copolymer, they form an easy-to-print, warp-free, everyday nylon with heat resistance up to 180 degrees and strength and toughness that lend itself to engineering applications. Polymide PA6GF is a glass fiber reinforced nylon 6 3D printing material. The addition of glass fibers improved the stiffness and tensile strength, transforming the soft, dampening qualities of nylon 6 into a rigid material with higher heat resistance. The glass fibers are much cheaper than the carbon fibers, which makes PA6GF a more affordable product while still offering superior mechanical properties when compared to a pure nylon. Polymide PA6CF uses carbon fibers to reinforce the material and contains 20% CF by weight. The carbon fibers offer even more in terms of tensile strength, heat deflection and impact strength. The carbon fibers also help to lower the coefficient of thermal expansion to create a warp-free 3D printing material with incredible properties. PA6CF is also an ESD safe material, as the carbon fibers help to dissipate any electrostatic charge buildup. If you're looking for outright performance, then PA6CF is unmatched in wet state properties. So what about PA12? While the first three materials have excellent mechanical properties, they all suffer from one thing, and that's moisture. Water particles suspended in the air as humidity are attracted to the nylon polymer chains and form a polar bond with the material. This changes the mechanical properties of the material from dry to wet state as the water molecule acts as a plasticizer. In some applications this can be advantageous as the material becomes slightly tougher, but we can assume that after printing, all materials will eventually end up in their wet state properties. PA12CF is much less sensitive to moisture absorption, which means that the filament in general is more stable, easier to use, easier to store, and easier to print. You'll notice a better printing surface quality when compared with PA6CF, and mechanical properties only witness a small shift from dry to wet state. This allows engineers to more accurately predict part strength and adjust their designs accordingly. So if outright strength, toughness, and performance is what you're looking for, then Polymide PA6CF is the best choice. If you can settle for slightly less strength but require stiffness and dimensional stability, then PA6GF is a better choice. For everyday engineering applications where strength, toughness, and wear resistance are critical, then Co-PA is an easy-to-use nylon. And finally, if you need predictable results, superior surface quality, moisture resistance, then PA12CF is the best option. All the materials in the Polymide family are designed for desktop printing and do not require a heated chamber or enclosure to print.